name is Dr. Pearce. I'm a PhD in biochemistry, and my background has been in diabetes research. We'd like to talk a little bit about how you can identify molecular structure. How do we know that we're finding fibroblastic growth factor? How do we know that the researchers found fibroblastic growth factor in the fertilized chicken embryo at day 9 of incubation? Well, there's some very specific tests that every research has to do. They do a double-blind research, and the particular molecular formula is subject, every one of them are routinely subject to very specific tests. One of them is nuclear magnetic spin resonance, there's chromatography, and there's polarimetry. However, this one is usually the one that is the most specific. And what happens is they take the substance, and let's say for the sake of example, we're going to use just a very simple one. This molecule right here is called methane. It has a carbon, and it is surrounded by 4 different hydrogen atoms. That's methane. So they put this in the machine, and then the resonance waves come out, very specific waves, spectrograph comes out, and it prints out on a graph what exactly that molecule it is. And according to the peaks on the graph, it's very, very specific. For instance, in the case of methane, you would see 4 small peaks and 1 large peak being the carbon. But where they are on the graph and the size of the peaks are very, very specific. It's more accurate or as accurate as DNA or fingerprinting. And so they know for sure that when they say they found fibroblastic growth factor and they tested using nuclear magnetic spin resonance, there is no mistake. You either have fibroblastic growth factor or you don't. And so that's how we can have confidence that this fibroblastic growth factor, which was discovered in the fertilized chicken embryo at day 9 of incubation, is in fact the real deal.